Okay, so we were doing alkanes, and the last thing that we did was the molecular formula and full structure formula for alkanes. Now we are looking at the physical properties of alkanes. So for alkanes, what you need to remember is that the thing that we are going to be talking about right now is melting and boiling point, right? And you need to know that alkanes are simple molecular substances. And what does this mean? So this means that the forces of attraction between the alkane molecules, let me write it as well, the forces of attraction between alkane molecules are going to be low. Now, how do we determine that the melting and boiling point are going to be low? So the forces of attraction is the primary thing that decides what is the melting and boiling point going to be. So if the forces of attraction, let's say if I talk about an CH4 methane molecule and I draw the structure, and we are saying that the force of attraction between them is low, that means when we put them under the conditions of boiling and melting points, breaking these molecules is going to be easy. So since the force of attraction is low, breaking these molecules are going to be easy. Hence the melting and boiling points are going to be what? Are going to be low, right? But this comes with the exception of if we talk about the general series. Let's say I'm talking about CH4, then C2H6, C3H8, and C4H10. Okay, so this is methane, ethane, and you have got propane and butane. But as we go down the series, right, as we go down the series, the melting and boiling points are going to increase. Why? Because see, here the reason for this was the number of atoms inside these molecules were low. Here you only had a total of 5 atoms, right, bonded to each other. Now as the number of carbon atoms increases down the series, what's going to happen is that the forces of attraction are going to become stronger. So what do we write down the series? Forces of attraction, I'm writing it as FOA, are stronger. And since the forces of attraction are stronger, the melting and boiling points becomes high. It generally goes from low to a high. So here, the melting and boiling point are low, and down, the melting and boiling points are high. Okay, and you can also see this with this table. So have a look at this table. You've got CH4 here, you've got CH4, and the boiling point is minus 161 degrees centigrade, and the melting point is minus 183 centigrade. And as you go down the series, what you're noticing here is that the boiling point is increasing. Okay, from minus 161 it's going to minus 89, and then minus 42, and then minus 1, and it's general pattern of an increase. So as the number of carbon atoms increases, the melting and the boiling points also increases down the series. Okay, so this is the concept of the physical properties, and this is the first part. We're just talking about physical, and we're talking about the melting and boiling point. One more thing that we need to do here is the concept of viscosity. Now, a lot of you would ask, what is viscosity, right? So you can take viscosity as the general resistance to the flow of a liquid. And I know it's difficult to understand, but we can do it with an example. So let's say we're talking about water. Now, water, if I turn a full bottle of water upside down, the water is going to flow very heavily, or you can say very fast, right? Water is going to flow very fast. And that is because water is a thin liquid, right? It's a very thin liquid. But instead of water, if I talk about honey, so honey, is a thick liquid. And if I turn the full bottle upside down of a honey bottle, it's going to fall, but at a relatively very slow speed. And this comparison between the speeds of flowing down, this is something that we call viscosity. Okay, what happens again here? So if I'm talking about CH4, C2H6, C3H8, and C4H10, and if I ask you what happens down the series, the answer is going to remain the same. What happens is that viscosity down the series increases. Why? It's a pretty straightforward thing. You see here the number of atoms are less. There are 5 total number of atoms if I include carbon and hydrogen. Here there are 14 atoms, right? So the molecular size is big and the forces of attraction are strong, which is definitely related to the melting and boiling points. But you can understand that as the size increases, the thickness also increases and the viscosity also increases. And what is viscosity? Viscosity is a comparison of how two different liquids flow from a bottle or flow from anything, right? So again, what happens? Viscosity down the series increases. Okay, this is one. Now the last thing is solubility. And this is pretty straightforward. How? Because we say that alkanes are insoluble in water, but they are soluble in most organic solvents. And you really have to study this thing in terms of theory only. You might get a question for 1 mark or so, and you'll have to only write either alkenes are soluble in water or not, or if they are soluble, what are the things that they are soluble in. So you'll write organic solvent, and I can just give you a quick example that they are soluble in CCl4, which is tetrachloromethane. Okay, and this is at max the best you need to know about solubility. So this ends our topic of physical properties of alkenes. Okay, bye.